Okay, so we're going to go through this package today. Monday is your opportunity to rewrite the Unit 3 exam at lunchtime. So it's only machine scored questions. Same as today, it'll only be machine scored questions if you're rewriting the Unit 4, if you signed up for that and have your review done. The review for Unit 3 is up here. If you went here yesterday, you can grab that after I'm done what I'm doing, going through this package. And that exam will be Monday at lunch. Again, only the machine scored, so you have an hour. You'll be able to get it done in an hour if you're prepared. I put a message on Google Classroom yesterday for you to sign up. There's a link there for the review this weekend. I think it goes from 8:30 to 3:30. And we'd like you to sign up to make sure that we have a room big enough. If more than 30 some people sign up, then we can't use this room, so I'll have to make arrangements to use another room. Also, there's going to be snacks provided, water, juice, granola bars, as well as I think Mr. Lobeda is going to get pizza for lunch. So we just need to know how many students are going to be here so that there's enough room and also enough food. So if you plan on being here on Saturday, then please sign up. The link is in Google Classroom. There's a message there. Okay? So let's go through this. The graph of y equals 3 to the x is reflected in the line y equals x. What's the equation of the transform graph? So you have to remember that when you reflect a graph over the line y equals x, that is the inverse. That's what we're talking about here. That is the transformation that occurs when you take the inverse. It's a reflection over the line y equals x. And to get the equation of the inverse, our first step was to switch x and y around. So if we start with y equals 3 to the x and we do the inverse, it'll be x equals 3 to the y. However, that is not one of the options we have. All four options that you have to choose from have y by itself, y equals. So we need to do that for this new equation that we just wrote. And to do that, you would convert from exponential to logarithmic. You'd start with the base and cycle through. The base of the exponential function is 3, so that'll be the base of the log. It'll be log base 3 of x equals y. Y equals log base 3 of x. So A was the answer there. So again, I mentioned this yesterday. You're going to have to be able to convert from one form to the other. It'll probably happen more than once on the exam. Start with the base, cycle through. Question 2, what's the value of that? Now you can't just do this in your calculator because there's one term, actually two terms there that have variables, right? But let's see how this works. So the first term, log base 5 of 625, I mean, you could get a numerical value for that because that's asking 5 to what power is 625. And I think that's 5 to the power 4, but you could also evaluate it on your calculator. If you have the log function, log base 5 of 625. So yes, it does equal 4. You can also get that by using the change of base identity. Log of 625, close the bracket, divided by log of 5. Whoa, try that again. There we go. So either way, the value of that is 4. Plus, this next term, 3 log base 7 of 49. Log base 7 of 49 is asking 7 to what power is 49? 7 squared is 49, so log base 7 of 49 is 2. Plus, Log base 2 of 1/16. That's asking 2 to what power is 1/16. That should be -4. But you can get that in your calculator whether you use the log function or the change of base identity. You'll get your answer of -4. Plus, log base b of b. That's asking b to what power is b. The answer to that is 1. If you use a change of base identity, it'd be log b over log b. Dividing something by itself gives you 1. Plus, the last term, log base a of 1, is asking a to what power is 1. The answer to that is 0. Anything to the power 0 equals 1. So the 4's cancel. You'll have 6 plus 1, which is 7, plus 0. The answer is 7. And remember, if this is a numerical response question on the diploma exam, there's 4 boxes. You always go left to right. So in this case, that first box will be filled in, but that's not what the computer marks. It marks what you bubble in below. I mentioned this yesterday. You've got lots of time. You've got double time. So you've got like 6 hours to write this exam. After you're done, I would go back and check to make sure all your bubbles are bubbled in correctly. And don't be late either. You might run out of time. Not going to mention any names or look at any one person in particular. Okay. So this next question is an SE, a Standard of Excellence question. Remember, there's always a certain number of questions on the exam. That's a Standard of Excellence. So you've got to usually do more than one step. It involves more than one outcome. Number 3, the equation m log base p of n equals q can be written in exponential form as what? Well, before you do that, you have to get the log part by itself. This log has a coefficient of m. We need to get rid of the m attached to the log by dividing both sides by m. So that'll be log base p of n equals q over m. And then we can convert from logarithmic to exponential by starting with the base and cycling through. The base of the log is p. That'll be the base of the exponential function. After the p becomes the power, which will be q to the m, equals n. So p to the q over m equals n. So B was the correct answer. Number 4 says rank those logarithms in order from least to greatest. So you just use your calculator to find the value of each one. First one, log base 4 of 62. Log base 4 of 62 has that value, 2.98. Log base 6 of 36 would be 2 because that's asking 2 to what power is 36. The next two will be irrational, so again, we'll have to use our calculator. You can use a log function or you can use the change of base identity. The log of 10 is 1 divided by log of 3, 2.096. And then the last one, log base 5 of 20. Again, you can use the change of base identity by going log 20 divided by log 5 if you don't have that log function, 1.86. So from least to greatest, the smallest one will be log base 5 of 20. The next largest number is 2, which was log base 6 of 36. The next largest number was 2.096, which is log base 3 of 10. And the largest is log base 4 of 62. So they're ranked from least to greatest. Question 5, what is that expression equivalent to? When you're multiplying powers with the same base, the law says you add the exponents and keep the base the same. So that's our first step. You're multiplying 2 powers with the base of 3. So you add the exponents and keep the base the same. Now that's not one of the 4 choices we have. However, when you're adding logs with the same base, you can use the product law. That'll be the same thing as log of x times x. or the log of x squared? Which is answer A. So there you go. That's the correct answer. Number 6, asked to write that as a single logarithm. So that first term would be log of x squared minus log of z. This is 1/2 log z. So dividing by 2 is the same as multiplying by a half. So that has a coefficient of a half, which can come up as an exponent. And then same thing with the last term. The coefficient of 3 can come up as an exponent. So I would put the positive terms together. And the log of z to the power a half would be the log of the root of z. And so now when we use the laws of logarithms and write this as a single log, it'll be x squared times y cubed over the root of z, which is answer A. That's where it came from. Number 7, given that log base 3 of A is 6 and log base 3 of B is 5, what is the value of that expression? That expression can be expanded using the product law. There are 3 factors inside the bracket. The first factor is 9, so that would be log base 3 of 9 plus log base 3 of A plus log base 3 of B squared. So we're using the product law to expand that expression. You're told that log base 3 of A is 6, so this will be replaced with 6. But for the last term, we're told log base 3 of B is 5. This is log base 3 of B squared. So we need to bring this 2 in front as a coefficient. Also, log base 3 of 9 is 2. That's asking 3 to what power is 9? Again, log base 3 of A is 6. But before we can deal with this last term, we need to bring the coefficient, the power in front as a coefficient. So now you have 2 plus 6, which is 8, plus twice log base 3 of B. We're told log base 3 of B is 5. So it's going to be 8 plus 10. The answer is 18. Once again, if this was a numerical response question on the diploma exam, those first 2 boxes would be filled in. And you have to make sure that you bubble correctly below, because that's what really gets marked, right? What you bubble in below. This next one is students work to simplify a logarithmic expression is shown below, where A is greater than 1. So step 1, you've got the expression, and then they start to simplify it. Where did they make their first error? So to go from step 1, looks like they brought all the coefficients up as exponents. So it'll be log base A of x to the 4th, all squared, minus log base A of x squared, all cubed, plus log base A of x cubed, all to the 4. And when you multiply 4 times 2, you'll get 8. So that's correct. When you multiply the 2 times the 3, you'll get 6. That's correct. And when you multiply the 3 times 4, you'll get 12. So that is correct. So to go from step 2 to step 3, what we've always done is we've collected the positive and the negative terms together. And then this will be log base A of x to the 8th times x to the 12th over x to the 6th, which is not what they have in step 3. They didn't put the positive ones together. And so the mistake is going from step 2 to step 3. So B is the correct answer there. Number 9, the equation of the asymptote for that graph. Well, remember that the graph of y equals log base b of x, the graph of a logarithmic function, has the y-axis as an asymptote unless it's been transformed. The x-intercept is 1. This is the graph of log base b of x. We saw that changing b will just change how steep the graph is. Is it flatter or is it higher? Okay. Now this graph will be transformed. It'll go 3 to the right and 2 up. The 3 to the right will change that vertical asymptote. Instead of being the line x equals 0, it'll be the line x equals 3. And you could put that equation in your calculator to see that. If you go to y equals and you type in, now we can use our log function here, log base, well, we don't have the opportunity or the option of putting a b in there, so we can just make up any base we want. But inside the bracket, you have to have x minus 3 and then the plus 2 on the end. Remember, changing the base just change how flat or steep the graph goes. It doesn't change the fact that the asymptotes will be different in any way. So zoom 6, set our windows to their standard settings. And now in this mode, the calculator doesn't show the entire graph. If we chose zoom decimal, which is number 4, we'll probably get a better look at it. Nah, not really. But you can go into the trace mode until y values start to appear. At 3 they don't, at 3.1 they do. At x equals 3.1 is where it starts. So this helps us verify that that vertical asymptote is at x equals 3, especially with the 4 choices that you have. It's the only one that would work. Number 10, the graphs of y equals log x is transformed to that by a translations of 5 units in what direction and 4 units in what direction. When we did these, we always got y by itself, by, in this case, adding 4 to both sides. So compared to y equals log x, the x is replaced with x plus 5, which means that h is negative 5. It's going to go 5 units to the left and 4 units up because k is positive 4. So B was the correct answer for that one. Number 11, for that graph, what is the domain? So we talked about this lots as we went through this course. To get your h value, b must be taken out as a common factor. That's what makes this question a standard of excellence. B must be taken out as a common factor to get your h value. In this case here, h is negative 4. B is 3, which remember causes a horizontal stretch by a third, but that doesn't change our asymptote. Our asymptote for the graph of y equals log base b of x is the y-axis, the line x equals 0. Multiplying 0 by a stretch factor of a third doesn't change that. However, when x is replaced with x plus 4 and h is negative 4, that's going to shift the graph 4 units to the left. So now our domain will become x has to be greater than negative 4 instead of x is greater than 0. What makes this question a standard of excellence question is taking the b value out as a common factor to get h, which is something that we did multiple times as we went through the course. I've said before, there'll likely be a question on the exam where you have to find one intercept of one function, either the x or the y-intercept. In this case, the y-intercept, remember, is always where x, the other variable, equals 0. So if we let x equal 0, we'll get y equals a to the 1, or just y equals a. There's where the y-intercept will be. Oh, I'm sorry, plus b. So it's a plus b. I missed that plus b there. So D is the correct answer. Number 13, algebraically solve that. So again, that means you have to show your work. You could definitely use the graphing calculator as a check, but if it says algebraically solve, then you have to show the algebraic steps. I would convert from exponential to logarithmic by starting with the base and cycle through. If you start on the left, that means the base is 8. That'll be the base of the log. Log base 8 of 4 to the x minus 9 equals 3x plus 4. The other option is you could take the common log of both sides, use the power law, and bring both coefficients in front, and then go from there. By doing it this way, you only got one exponent that you bring out front. That's the one on the left, because that's the log. So the x minus 9 comes in front as a coefficient. We'll multiply out those brackets. Because remember, you need to solve for x, so you need to get x by itself. We will collect the terms with the x's together on the left. So I've got the x log 8, log base 8 of 4, I should say. I'll subtract the 3x from both sides. I'll keep the 4 on the right, and I'll add the 9 log base 8 of 4 to both sides. You know what? I'm sorry, guys. This is going to work, but we also could have done this by making the bases the same. So I'll go back and do that. It'll be a little bit easier, but this will work as well. It'll just take a little bit longer. So taking out a common factor of x on the right gets x by itself. And then you divide both sides by what's inside the bracket and go to the calculator. So we'll open brackets so we keep the numerator together. So 4 plus 9 times log base 8 of 4. Close the bracket on the numerator, and I'll divide that by the denominator, which I'll also put in brackets, log base 8 of 4. And some of you might be wondering why you don't just cancel the log base 8 of 4s. Well, because on both the top and the bottom, those are parts of binomials. You can't cancel part of a binomial. You have to be able to cancel the same number in all the terms for that to work. So log base 8 of 4, take away 3, and close that bracket. Gives us that decimal, which, if I turn it into a fraction, it's negative 30 over 7. Which is what we would get if we do this by making the bases the same. 8 can be written as 2 cubed to to the 3x plus 4. And that must equal 4, which is 2 squared to the x minus 9. You multiply out the exponents. You'll get 2 to the 9x plus 12 equals 2 to the 2x minus 18. The bases are equal, so the exponents will be equal. Subtract the 2x from both sides, we'll get 7x there. Subtract the 12 from both sides, we'll get negative 30. And then divide by 7, you get the same answer, negative 30 over 7. Quicker for sure. Making the bases the same is always going to be quicker. But both methods work. For the next one, though, we won't have any choice because we can't make the bases the same. So, start with the base and cycle through. If I start with the left with a base of 3, that'll be the base of the log. Log base 3 of 1/5 to the power x minus 3 has to equal 2x plus 1. When we change from exponential to logarithmic, start with the base, cycle through. The exponent x minus 3 comes out front. And then we multiply out the brackets. We're trying to solve for x. We need to get x by itself. So again, I would collect all the terms with x together on one side. I'm going to collect them on the left side, which means you're going to subtract the 2x from both sides. And on the right side, I'll leave the positive 1 there, and I'll also add 3 log base 3 of 1/5 to both sides. We're trying to get x by itself, so on the left side we can take out a common factor of x. And then we divide both sides by what's inside the brackets. And again, you cannot cancel the log base 3 of 1/5 on the top and bottom because they are terms of binomials. You can't cancel parts of a binomial. We're only allowed to cancel the same factor in all the terms. If all the terms are divisible by the same value, we can do that. But again, that's not the case here. So this does ask us to round to the nearest hundredth. So 1 plus 3 log base 3 of 1/5, 1 divided by 5. So there's the numerator in brackets divided by the denominator, which I also need to put in brackets. Log base 3 of 1/5 minus 2. So to the nearest hundredth, it'll be 0.98. Which you could confirm on the calculator by graphing. The left side is 3 to the power 2x plus 1. The right side is base of 1/5 to the power x minus 3. If we graph them and find the point of intersection, you get the same decimal. Okay. Exactly the same decimal that we did algebraically. Okay, so can definitely use the graphing calculator to check, or, and I doubt you would get a question like this on a multiple choice or a numerical response. I doubt you would. But if you did, then there's no work to show for those. You can use your graphing calculator. So this one has outcomes that make it acceptable as well as standard of excellence. Solve algebraically. So what you want to do, because the left side are both logs with the base of 7, you can combine them using the product law. Because it's the sum of logs, this will be log base 7 of x plus 1 times x minus 5 equals 1. If we multiply out those binomials, we'll get x squared minus 4x minus 5. And now we will convert from logarithmic to exponential. It'll be 7 to the power 1 equals x squared minus 4x minus 5. And obviously 7 to the power 1 is 7. We've got a quadratic on the right. There's an x squared and an x. So to solve that, we have to factor. But we first need to make it equal to 0, which will give you minus 12. And the factors of that quadratic, whoops, would be x minus 6, x plus 2, which gives us two answers for x, 6 and negative 2. But negative 2 is extraneous because we have restrictions on x. Remember, you cannot take the log of 0 or a negative number. So for the first term, x has to be greater than negative 1. For the second term, x has to be greater than 5. The domain for this equation will be x has to be greater than 5. That is the restriction that satisfies them both. So that is why negative 2 is a extraneous root. You have to cross it out or write that negative 2 is extraneous. You have to do something to show that that one doesn't work. And you can also check your answer in the original equation. When x equals 6, you'll have log base 7 of 6 plus 1 plus log base 7 of 6 minus 5. 6 plus 1 is 7. 6 minus 5 is 1. Log base 7 of 7 is 1. That's asking 7 to what power is 7? Or if you use a change of base identity, log 7 over log 7 gives you 1. The second term will be 0. That's asking 7 to what power is 1? 7 to the 0 is 1. And if you use the change of base identity, log of 1 divided by log of 7, it does give you that value of 0. And obviously 1 plus 0 is 1, so it checks. Get the same thing on both sides. So we saw questions like these in the notes. Earthquake intensity is given by I equals I sub 0 times 10 to the m, where I sub 0 is known as the reference intensity, m is the magnitude. An earthquake measuring 5.3 on a Richter scale is 125 times more intense than a second earthquake. Determine to the nearest tenth the Richter scale of the second earthquake. So I sub 2, the second one, is 125 times more intense, or the first one I should say is 125 times more intense than the second one. So that means if you divide those two intensities, the quotient of the intensities will be 125. So using that expression, that equation that we're given in the question up here, I is the intensity, so I'm saying I sub 2 will be the intensity of the second earthquake, and that will equal I sub 0 times 10 to the power 5.3. And if I divide that by I sub 1, and actually I've got these backwards, is more intense than the second. So this actually should be I sub 1 and I sub 2. No, I'm sorry, I had it right to begin with, because we want to find the Richter scale measure of the second earthquake. So I did have it right to begin with. So this will be I sub 2 over I sub 1. If you divide these two, the one earthquake is 125 more intense than the other, so that would be the quotient when you divide I sub 2 and I sub 1. When you divide the I sub zeros, they will cancel. And when you divide the powers with bases of 10, you would subtract the exponents and keep the base the same. And to find out what m is, I would convert from logarithmic to exponential. Start with the base and cycle through. So that'll be 10 to the power 125 equals 5.3 minus m. I'm sorry, log base 10 of 125. I'm converting to logarithmic. And the nice thing about this is, again, it's a log with a base of 10, so that's a common log. You can just go log of 125. Which is 2.0969. And this is actually going to give you, oh no, we're good. So negative m will equal that decimal minus 5.3, which is negative 3.2. So you'd multiply both sides by negative 1, and you'll get 3.2 as the magnitude of the second earthquake. Okay. Number 17, population of a particular town on July 1st of 2011 was 20,000. Population decreases at an annual rate of 1.4%. How long would it take for the population to reach 15,300? So if you work with the exponential function equation that we're given, the amount at the end is what y is, that's 15,300. A is the initial amount, which is 20,000. B, the base, is the growth rate. If it decreases by 1.4%, that means it's maintaining 98.6% of its population. That's the number that you have to use, 0.986. And T is the time in years over P, the growth period, which is 1, because it's decreasing by an annual rate of 1.5% per year. So the growth period is 1 year. And T divided by 1 is just T, and we need to solve for T. We would start that process by dividing both sides by the 20,000. Which gives us 0.765. And that'll equal 0.986 to the power T. And then to solve for T, we will convert from exponential to logarithmic. We'll start with the base and cycle through. It'll be log with a base of 0.986 of 0.765 equals T. So log with a base of 0.986 of 0.765. So approximately 19 years for that to happen. All right. So Monday is your opportunity to rewrite this exam. Tomorrow we will start going through trigonometry and finish that on Monday. And then Wednesday will be your chance to rewrite the trig exam. Okay? So for those students that are doing the Unit 4 rewrite, you need to hand your assignment there. You need to give them a few minutes to check them all over to make sure they're complete. And then I will hand out the exam for you. If you need some more time, then that's fine. But you have to start at the end of class because you've only got till the end of lunch to do it. So, okay. Don't forget to sign up for the review on Saturday if you want to attend that.